So this video will be about waves. Different wavelengths of the electromagnetic spectrum have their own properties that are useful. For instance, there are X-rays that let us see inside us, visible light, which allows us to see everything else, and radio waves. In this video, we'll be talking about the Doppler effect, reflection, diffraction, and diffraction patterns. So polarization, standing waves, types of waves, and resolution, but not necessarily all in that order. So just some basics before we go any further. There are two different types of waves, longitudinal and transverse waves. Longitudinal waves means that the oscillations are parallel to the direction of the wave, whereas transverse waves oscillate perpendicular to the direction of the wave. And then we need to learn some of the basic terminology. The wavelength, which is the length of one oscillation, is given by the Greek letter lambda. The amplitude, which is the maximum displacement from the middle point, is given by capital A. Note that the x-axis in the first graph is displacement, whereas in the second is time. The period, given by the letter capital T, is the amount of time it takes for one full cycle to complete, whereas the frequency is the number of cycles in 1 second, or the reciprocal of t, given by lowercase f. Next, we'll be talking about reflection. So reflection happens whenever a source of light hits another object. If the object in question is completely smooth, all you need to know is that the angle of incidence, represented by theta subscript I, will equal to the angle of reflection, given by theta subscript r. Next, refraction is what happens when light travels through two different mediums. Basically, the wavelength and the speed of the wave are reduced in this example when it hits water, and so as a result it bends towards the normal. Thus, theta subscript I, or the angle of incidence, is greater than the angle of refraction, or theta subscript r. When light passes through a single slit, it diffracts and interferes with itself, creating these dark spots along the place wherever it's hitting. We will let these angles by which the light is diffracted be theta. Through similar triangles, the angle here is also theta. We will let the width of the slit be b, lowercase b. So, when the two beams hit each other, they interfere, and they create this black fringe over here. So to calculate the nth fringe's distance x from the middle, you can use the formula x equals 2n minus 1 all times the wavelength lambda, all over 2. So if we redraw this section over here, we can calculate theta with theta equals 2n minus 1 all times the wavelength lambda over b, the width of the slit. So the first fringe's distance, x, is given by lambda over 2, the second fringe by 3 lambda over 2, the third by 5 lambda over 2, and so on. As we know, for the angle theta of the nth dark fringe is given by theta is equal to 2n minus 1 all times the wavelength lambda all over b. But for circular apertures, it's a bit different. The angle is given instead by theta equals 1.22 times 2n minus 1 all times lambda over b. Why 1.22? Well, that's because of something called Bessel functions. And what are those? We have no clue. Just take our word for it. It's complex math that you don't have to know for this. The rest of the stuff, like the Doppler effect, polarization, and other things, will be covered in other videos yet to come. Thanks for watching.